All right. Now, so in this lesson, we're going to take a trinomial like x squared plus 7x plus 10, and we're going to break it into its pieces, and you got to figure out how to do that. So the very first thing they do in the book is they show you get some algebra tiles. I find this a little bit hard. I probably won't make you exactly using algebra tiles, but we can kind of play with it. So let's consider this first diagram. So algebra tiles are new to some of you because if you didn't do ninth grade with me, it can be new. So if I had to write down what the answer was, write the polynomial expression which is represented by these algebra tiles. What would you write? X squared. Go ahead. Oh.
6x.
Is there 6? Okay. And then what?
Plus 4.
Plus 4.
Plus 8.
There's 8 over there, yeah. Okay, do you agree? Y'all agree that that's what those algebra tiles represent? They're all positive, right? They're all gray colored. And that's what they could represent. Y'all agree? So far, so good? Okay, so that part's not hard. Then it says, okay, what if we had to arrange them and make a nice rectangle out of it? Now, this takes a little practice, to be honest with you. If I just throw some algebra tiles on the desk and I say, make these into a nice little rectangle with no pieces sticking out and no holes and gaps in it, it actually is a little bit hard. But they did it for us. So notice they have a little 8 down here on this little corner down here. There's 8 of them there, right? And they had to split the 6x blocks into 2 and 4. See it? And so then it says, write an expression for the length of the rectangle. What do you want to call length this? We'll call this length. So what expression is that? What would I write down here or up here? X plus 2. Okay, that's the length of it. Write it down. I don't know which one is length and which one is width. It depends. And let's write one for the width. So let's go this way. So what is that? X plus 4. Okay. And then it says write the area of the rectangle as a product. What does the word product mean? Quick. Multiplication. Yep. So I'm going to have two things multiplied together. It's going to be the area. And it's going to be x plus 2 times x plus 4. Agreed? So far, so good? Do you have a pencil, Joey? Okay. And then it says write it in expanded form. So what does it mean to expand? Get bigger. Get more. How about to multiply? God said go and multiply. Fill the earth, right? Like expand the human population. Okay, we're getting bigger. So we're going to multiply this out. So when we do that, we get x squared plus 4x plus 2x plus 8. Y'all click on that draw now. Hopefully you've been practicing that. We did that all last chapter. Yeah? Okay, and so then if I was to simplify, look at that. X squared plus 6x plus 8. So somehow we got to figure out, because this is kind of complicated to take your algebra tiles and make them fit. I mean, we could try it. So there's got to be a method. So I'm not actually going to do this part A and B, but can you think of the relationship between this 8 and this 6? From my factors, like going from here, is there a way I could get there by looking at this right here? How do I get to factored form from the original? Anybody know? Anyone pick up what goes on?
2 times 4.
Oh, Miles is saying the 2 times the 4 makes the 8.
Like the X.
And then say again, Miles. He said 2 times 4 is 8, and 2 plus 4 is 6.
Oh, and then the 2 x's are x squared.
Yeah. Let's go see if that works. Turn the page. We're going to go all the way down here to investigation factoring trinomials by inspection. Okay, so go all the way down to the middle of the next page or something. Okay. So here they want us to expand it. So notice what happens when it's x plus 3x plus 3. What are you going to get? X squared plus 3x plus 3x plus 9. Write quickly, right now. Go. In fact, I'll do some flippity stuff and figure out for people, you guys, to do the next ones. So, of course, when we finish this, we have x squared plus 6x plus 9. Miles, is your theory working? Yes. All right. Who's next? Gabe, can you expand this next set of brackets for me?
X squared
Uh-huh.
plus 8x.
No, do 1 out of 10.
Oh, 1x plus 7x.
7x plus
X
1x,
plus 7.
plus 7. So combine that together, you have x squared plus 8x plus 7. Does Miles' theory still work? 7 and the 1, multiply to get the 7, and they add together to get the 8. Is that true? Okay, Cece, next.
X squared
Uh-huh,
plus 2x
uh-huh,
plus 5x
yeah,
plus 10.
excellent. Okay, let's combine those together. You have x squared plus 7x plus 10. Okay, we're looking at these terms here most importantly, and I'm looking at this. If I saw x squared plus 7x plus 10, how could I get x plus 5 and x plus 2? Does Miles' theory work? Do these factors multiply together to get 10 and add together to get 7? They do. Let's try one more. Thomas. Next one.
X squared minus 5x minus 2x plus 10.
Okay. So this one is almost the same. Does it make sense that this would be a -5 and a -2 that would still give you a +10?
Yes.
And would it make sense that a -5, if you added or combined that with a -2, would still give you a -7? Think money. You owe 5, you owe 2, you owe 7. Ooh, how did we have this? I think we could do it. Let's try one more. Okay. Levi, can you work this next one out for me?
8 squared.
We're gonna start with your x's.
Yeah. 8 squared.
X squared, that's okay.
Minus 6x
Uh-huh.
plus 8x
Yeah,
minus 48.
perfect. Okay, so we're gonna combine those two middle terms together because I'm going combining, right? Hey, by the way, any farmers here? You got all your combining done?
Yeah.
Yeah? Everybody's yes? It's pretty early this year is what I heard because it was so dry. Yeah. Before Thanksgiving. Yeah. Glad you have it in. Probably didn't go as good as some years, but at least it's done. Okay, now does his theory still work? Let's look. Does the 8, the +8 and the -6 multiply together to give me a -48? So we're going to watch our signs. And does it combine together to give me a +2x? Yeah. All right. So that's the connection. So the values, this value of B, how does it relate to P and Q? You add them together, right? And the C, how do we get the C from P and Q? You times them together. And that, ladies and gentlemen, is how you factor. Right there. So let's go see if we can get some examples. Part of the reason why this works is because there is no number in front of the x squared in any of the examples. Did you see that? In all of these examples, there is no coefficient of the x squared term. So the only numbers up there are the last constant and that middle x. So when there is a number in front of the x squared, we're going to have to change our thinking just a little bit. Some things still apply. All right, let's go down here. I do not use FOIL. Skip that. I am just going to go right to this next factoring by inspection. So whatever page it's on. Okay. The reason I don't use FOIL is because it only works if you have a binomial and a binomial. And as soon as you go to 3 terms in a binomial, you can't use FOIL. So why do we do that at all? I don't know. So here it says, let's just reiterate, if we were going to factor this or break it into its pieces that multiply together, we would need to find 2 numbers that multiply together to get what? When they multiplied, did they get the 8 or the 12? So 12, yes, write that down. They have to multiply together to get 12, and they have to combine or add together to get what? 8. So what would you choose if we were going to do this? We would have to go x and x.
6 x.
We would use 6 and 2, wouldn't we? Do those numbers multiply together to get 12? And combine together to get 8? Yeah, and then my signs would all be positive, right? Now, if you don't know if that's right, could you figure it out? What could you do to figure out if these two brackets multiply together give you back the original? What could you do? Hurry up. What could you do? Go ahead and multiply it on out. Go ahead, expand it. So you go there. Yeah. That's what we've been doing, right? Just do a little quick check down here. Oh, check mark. It works. 6. Oh, no, sorry. Back up, delete. 6 times 2 is 12. Okay. Does it work? Do I get back to my original?
Yep.
Yes. So your answer is the pieces that are factored. Okay. That was just my check. Those two brackets are my factors that multiply together to give me the original. You with me? Okay, but you can always do that little check. Let's do this one. In order to factor x squared minus 13x plus 12, we need to find two numbers that multiply together to get what? 12. And combine or add together to get what? Negative 13. Don't forget it's a negative on there. Oh, anybody know what you would choose? We're going to go x and x, so that makes our x squared. What would you choose, Malachi?
1 and 12.
1 and 12.
Negative.
And if you make them both negative, two things have to work. Does a negative 1 and a negative 12 multiply together give you a positive 12 for the last term? Yes. If you combine now, does a negative 1 and a negative 12 combine together, Kale, to give you a negative 13? Okay, I need you to move to the front row, please. Right here. Does it work? Victor, does it work? Don't really know, not paying attention. Negative 1 and negative 12 combines together to get negative 13. It does. We're good. Okay. So they're going to have you start working on that. Always, I don't know why they put the sum first. Look at the product first. Always look at the last number first and come up with the numbers that multiply together to get that last term. So if we were thinking of the two numbers that multiply together to get 20 and combine together to get 12, what would you choose? 5 and 4 multiplies together to get 20, but it does not add together to get 12. So you scratch that off your list and you try again. Okay, 1 and 20. Nope. How about 2 and 10? Yes, so let's try 20. Oh, I see what you're at.
Yeah.
Jace was moving on. He was already on this one. So he says 5 and 4. Does that work?
Yep.
Multiply to get 20, add to get 9. Okay, good. How about 4? Careful.
2.
Why not 1 and 4? Because they don't add to, yeah, you're right, 2 and 2. Okay, how about 18? 6 and 3. But if you had a negative 6, he's saying, and a negative 3, they would give you a positive 18 if you multiply them. Joey, did you write that down? And when you combine, you get a negative 9. So Joey, you're on the next one. I need two numbers that multiply together to get 14 and combine together to get negative 15. What would you choose? Right here. Any ideas? We're going to ask Joey. Do you know what they are? Numbers that multiply together to get 14. Let's just go through 14. How do you get a 14? 7 and 2. Are there any other options for 14? 14 and 1. Okay, so you can write them all your options down. In this case, there's only two different options. Now, which ones would you choose that could combine in some way to get negative 15? The 14 and the 1. Okay, now we better put signs on them. You have to owe a lot. You have to owe all of the 14 and all of the negative 1. You've got to owe it. And then they multiply together to be positive. Got it? Okay. Ben, we want to get some numbers that multiply together to get a 6. We'll worry about signs after. Let's get our 6 first. How do you get a 6? You could do a 1 and a 6.
Yeah.
Or,
But wait, that has to be negative, right?
well, don't worry about the signs first.
Oh, okay.
Just give me the ways to get a 6.
1 and 6.
Or,
2 and 3.
okay, 2 and 3. Now, they have to combine to get a 1.
So 1 has to be positive. 1 has to be negative.
Yeah. Would I use 2 and 3 or would I use 1 and 6?
2 and 3.
2 and 3. Okay. I'm going to use 2 and 3. Now, he's right. One has to be positive and one has to be negative. So which one will have to be a negative?
Three.
The 3, because you have to owe more in the end. You have to be owing. When you're all said and done, you owe $1. Correct? When you're all said and done, you have to owe $1. All right. What if it's negative 15? Sydney, how do you get 15? 5 and 3. Do you think those are the answers? Probably. Okay. So 5 and 3 would make a 2 in some way. So if I had a positive 5 and a negative 3, would you be left with a positive 2?
Based on the.
You had $5, you owed 3, you'd still have 2. You with me? Okay, how about 48? What are some factors, some things that multiply together to get 48?
24 and 2.
24 and 2. Are there other ones that make 48? How about 6 and 8? Come on, give me some more. 12 and 4. Don't ever forget 48 and 1. It is a possibility. It's not usual, but it is there. Are there anything else? 16 and 3. That's one. 1, 2, 3, 4, 6, 8. I think that's it. So which one of those would we choose that you could get a 26 out of it? 24 and 2. And let's talk signs now. So choose your numbers, and then do they both have to be negative? Yeah. Do those multiply together to get a positive 48? Yes. Okay. Good. That's the gist of what you're going to do here. This little stop sign guy, he has important things. If the product is positive, then you know they're both the same sign. They're both negative, they're both positive. And if it's negative, there's one of each. Okay? All right. So let's go factoring. Let's do D, E, and F. Okay? There is nothing common to pull out. Here we go. There's nothing common to take out of this trinomial, correct? So I'm going to go to 2 brackets directly. What are you going to choose? Okay, we're going to start with A and A. Sariana says 10 and 1. You could do 5 and 2, but that wouldn't give you an 11. So we're going to go with 10 and 1. And what are we going to choose for signs? Negative. Are both negative?
Yeah.
Will that work? Are you sure?
No, because that's being negative 11, right?
Yeah, let's go try it. This is my practice. A squared minus A. This is my check. Does that work?
So.
Do I get my negative 11?
Yeah.
I do.
1 and
Good. Yeah, it works. So you could always go check. Your check is not the answer. It's just your check. The answer are the things that multiply together. You were told to factor, and factor means to break into 2 pieces that multiply together, or 3 or 4. Doesn't really matter. Okay, E, ready? Nothing to take out of that. Nothing to take out of that. There's nothing common to every single term. So I will go directly to 2 brackets. Okay, what do I need in there? Y and Y. What are you going to choose for 4?
4.
4.
No, that one.
I think we're all kind of stumped.
Yeah, that one's a little tricky.
What NP stands for?
Well, not.
Not possible. This is not possible. You could go with your 4 and your 1, but you need one of them to be a negative. You can't have anything negative because it's all positive. Right? If you made this positive and this negative, go do your check. It won't work. You'll get your +3, but you won't get your +4. You'll get a -4. Agreed? So sometimes they're not possible. This is not right. Okay, next, F. Here we go. Nothing to take out of that trinomial. There's nothing common to every single term. So we will go directly to 2 brackets. How do we get started? X and X. Okay.
25 and 2.
25 and 2, or 5 and 10, or 50 and 1, but 25 and 2, you're quite confident?
Yeah.
25 and 2, yeah. Everything's a positive, and that will work. Okay, let's go down here. Okay, getting the drift? Okay, let's go down and let's try some bit more complicated. Okay, you look at 4x squared minus 32x plus 4. Oh, yes.
Why is there an X in 27?
Let me show you. That's a good question. Because watch what happens when you multiply this out. Ready? This is my check. You see it?
Yeah.
So she was wondering, how does that get there? Well, right from these two things right there. Good question. If something doesn't make sense, it doesn't do you any good to go on, right? Let's learn it. Okay, good. Question 6A here. Factor the polynomial expression, and it says first remove common factor. So is there a common factor to remove from every single term? What could you remove from every single term? A 4? Anything else? Just a 4? Okay, here's the ticket. When you remove a 4, or divide out a 4,
I'll give the X words to him.
you have to leave everything that you needed there. We do not go to 2 brackets. First step is 1 set of brackets. If the first step is not possible, then we go to the second step with 2 sets of brackets. First is 1, second is 2. It's not complicated, right? First is 1, 2, second is 2. With me? Someone not? Okay, thank you. So I'm going to remove or divide out the common factor first. What will be left?
X squared,
8
negative.
minus 8x plus 12. Don't forget to put signs in there. You gotta put your signs down. You must put your signs down. Okay, notice that when I remove the common factor, divide out that common factor, I have to leave what is left in 1 set of brackets. Now, that's number 1. 1 set of brackets. Look, how many times can I say that? First step is 1 set of brackets. The second step, okay, is 2 sets of brackets. I have to leave my 4 there. He has to come along, okay? He's just part of the deal. But now I can ignore him and just bring him along and go ahead and factor what's left there, that trinomial. So x and x, what are your things here?
6 times 2.
6 and 2, that'll give me a 12. And what signs do I need? Both of them? Yeah. Good. How many factors are up there? How many pieces multiply together to get the original? 3. There are 3 factors.
4.
The 4, the x minus 6, and the x minus 2. All of them are necessary to get 4x squared minus. Okay, good. Part B. What are you going to do first? Remove the common factor first. And there's a 3. Anything else?
X.
Good call. You must leave 1 set of brackets in the first step. We're only in step number 1. Leave 1 set of brackets. No matter how many times I say that, guaranteed I'll come over to your thing and say, well, when you take out the common factor, you have to leave 1 set of brackets. Okay. What do we have left?
X squared
Plus 7x. Plus 10.
Good. Copy down the 3x. Don't forget him. And go about factoring your trinomial like you would have every other time. We're going to get an x and an x. What's your numbers going to be? 5 and 2, both positive. All right, there you go. How many factors are up there? No. 4. There's a 3, an x, a bracket, and another bracket. There are 4 factors up there. Guys, you could do this. We don't do that, but you sure could, couldn't you? Tricky. Yes.
So if it was 3x squared, would that mean it was 5 or would it still be 4x?
Oh. That's a good
They just
question.
write these things like this just to be crazy.
I think you could say there was 5. Because x squared is x times x, right? That's a good question. I've never been asked that before. Okay. In this example, there were 2 steps. I'm done. Okay. 2 steps in the factoring process. Here it is. He's the stop sign guy. Read him. A common factor, then there's a trinomial. If we are asked to factor a polynomial expression, it is understood this means to continue factoring until no further factoring is possible. You must always factor fully, okay? You are not done. So the word factor, I don't want anybody to say, well, it didn't say factor fully, okay? No, that's what that means. Anytime we say factor, it's like you never leave me a fraction like 8/16, okay? You never leave that. You don't even leave 4/8. No, you don't. No, you don't. You get all the way to 1/2, right?
Because
Yes. So you factor fully. Okay.
for 2 reasons.
Away you go. Did I make you do question 1?
Yeah,
I-
not 2.
Just 1. Okay, try to figure that out. Do you want algebra tiles? So you don't have to mess around in your paper. If you would like to try it with actual algebra tile blocks, you don't have to keep writing things on your paper. You can. There you go.
What doesn't work?
Where for you guys?